This is sections 4.5 and 4.6 of Honors Algebra 2, factoring polynomials. So what does it mean to factor something? Well, to factor a polynomial is to express it as the product, so the multiplication, of other polynomials of lesser degrees. So if we have a polynomial of degree 2, sometimes we can factor it into a polynomial of into a product of two polynomials of degree 1. When we're factoring, here's some steps we can follow. First, we want to find the GCF of all the terms of the polynomial. If that GCF is 1, if the greatest common factor of all of the terms is 1, then we move on to the next step. If it's something other than 1, we want to factor out that GCF. Put it in the front with a set of parentheses, and what's left will go in that parentheses. If what remains, if what's left, is two terms, a binomial, then we want to look for either a difference of squares or a sum or difference of cubes, and we'll see examples of both of those. If instead it's a trinomial, 3 terms, then we can factor that, and I'll show you how to do that and remind you how to do it because you've done it before. If it's 4 terms, what we might call a quadrinomial, then we can go 2 and 2 or 3 and 1, and then factor each group and go from there. So all I'm going to do in the rest of the video is a bajillion examples, 15 or exactly 15. So example number 1, x squared plus 6x plus 9. Greatest common factor of the 3 terms is 1 because x squared has a 1 in front of it, and so there's nothing else that will divide into it. So we proceed. It's 3 terms, it's a trinomial, so we try to factor it. Here's how we factor a trinomial. If the number in front of x squared is 1, like it is here, we take the last term, 9, we find factors of 9. That will add together to give us the middle number, which is 6. So factors of 9 would be either 1 and 9 or 3 and 3. Now which pair of those will add together to give us 6? 3 and 3, obviously. We want positive 3 and positive 3, those add to give us positive 6, and positive 3 times positive 3 is positive 9. So we factor it as 2 sets of parentheses like this, where we have x plus 3 and x plus 3. It's plus on both of them because they're both positive. We can always check our answer when we factor by simply foiling it out, and we should get back our original problem. And we would here. So that is factored, x plus 3 times x plus 3. However, since those are the same, we can write it as x plus 3 squared. And that's really the way we should write our answer here. It is what's called a perfect square trinomial. It's a trinomial that factors as a square of a binomial. So that is a perfect square trinomial. Our original problem is a perfect square trinomial. It factors as the square of a binomial. Number 2, 2x to the 4th minus 4x cubed plus 8x squared. We look for a greatest common factor. We notice that all 3 terms have a factor of 2, so we can take a 2 out, and we also notice that all 3 terms have x's. So we can take out x's, and the most we can take out are 2 x's, x squared, because that is the lowest power of the variable. We factor a 2x squared out of everything. That means we're going to divide each of the terms by 2x squared. So 2x to the 4th divided by 2x squared, 2's cancel, and we will get x squared. Negative 4x cubed divided by 2x squared is negative 2x. And positive 8x squared divided by 2x squared is positive 4. The x squareds would cancel. Okay, now we can try to factor what's in parentheses, x squared minus 2x plus 4. So we look for factors of 4 that add together to give us negative 2. Well, factors of 4 would be 1 and 4, or 2 and 2. Okay, and even if I made one of them negative, well, if I made one of them negative, they wouldn't multiply to give us a positive 4. So I either have to have them both be positive or both be negative. Either way, they're not going to add together to give us negative 2. So that means what is inside the parentheses is called a prime polynomial. It cannot be factored. It cannot be broken down any further. So our answer then is just what we have here, 2x squared times x squared minus 2x plus 4. That is factored completely. We cannot break it down any further. Number 3, 10ab cubed minus 15a squared b squared. We look for a greatest common factor. Notice I can take a 5 out of both of them, so I'll take a 5 out. They also both have an a. I can only take one a out because that's all the first one has. They also both have b's. I can take two b's out, so b squared, because that's all the second one has. If I take 5ab squared out of this, 10 divided by 5 is 2. A divided by a is a. B cubed divided by b squared is b. So I've got a 2b there. Minus 15 divided by 5 is 3. A squared divided by a is a. B squared divided by b squared is 1. So when I factor out 5ab squared, I'm going to end up with 2b minus 3a. Notice there's nothing squared there, so there's nothing left to be factored. I can't break it into a polynomial of a lower degree, because the lower than 2 is 1, and we've already taken out the greatest common factor, so there's not going to be another monomial factor we can factor out. Number 4, x squared minus 16. Greatest common factor is 1, so I can't do anything with that. So I have two terms. What do I look for when I have two terms? I look for either difference of squares or sum of cubes or difference of cubes. Well, since x is squared here, we should look for a difference of squares. And a difference of squares means two terms, each of which is the square of something that we know. And they are subtracted. That's what makes it a difference. So this is indeed a difference of squares. It's only a difference because it's subtracted. If there was a plus there, we could not do this. But since it's subtracted, since there's a minus in the middle, we can factor it as a difference of squares because we know the square root of x squared is x. X times x is x squared, so I'll put that in the first position in both my sets of parentheses. And we know the square root of 16, it's 4. So I'm going to put a 4 in the second position in both sets of my parentheses. And then the way a difference of squares works is we make one of them minus and one of them plus. And the order we do those in doesn't matter because we can change the order of these sets of parentheses. We can change the order we multiply in. So that's how a difference of squares works. You take the square root of the first term, put it in the first position in both. Take the square root of the second term, put it in the second position in both. Make one of them positive, one of them negative. So number 5, x cubed minus 8. Greatest common factor is again 1. It has two terms. This time x is cubed, so I'm going to do a difference of cubes. How do I know it's a difference? Because x cubed and 8 are subtracted. So this is a difference of cubes. And here's how a difference of cubes works. You take the cube root of each of the terms, so the number that we would multiply by itself 3 times to get each one. Well, the cube root of x cubed is just x. I'm going to put that there. And then we take the cube root of 8. So what number do I multiply by itself 3 times to get 8? That would be 2. 2 times 2 is 4, times 2 is 8. So 2 cubed is 8. So I put a 2 in the second position in my parentheses. And then the sign in the middle is the same as the sign above it. It was x cubed minus 8, so that's going to be x minus 2. That's the first part of my factoring. The second part is going to be a trinomial. And I get that trinomial by taking that first term, x, squaring that. I take the last term, the 2, I square that and I put it all the way on the other end and make it positive. It's always going to be positive there. And in the middle, I'm going to take each of these terms, the x and the 2, and I'm going to multiply them together. 2x. The sign of that term is the opposite of the original sign. So again, I took the cube root of x cubed, that's x, and the cube root of 8, and that's 2, and I put the sign in the middle of them that is the same as the original sign, so x minus 2. I squared the x, and I squared the 2, and I put those on either end of the second set of parentheses. In the middle, I took the 2 of those, 2 and x, and multiplied them together. I made that middle sign the opposite of the original one, and I made the last sign positive, and that will always be positive. So that is how we factor a difference of cubes. And we could try to factor x squared plus 2x plus 4 further. We'll notice that we can't. Factors of 4 are only 1 and 4 and 2 and 2. Neither one of those will add together to give us 2. And anytime we do a difference of cubes or a sum of cubes, that will always be the case. We won't be able to go any further if we have a quadratic trinomial left. Number 6, 2t to the 4th plus 54t. Look for greatest common factor, and notice I can take a 2 out of both of them. and I also can take a t out of both of them. That leaves me with t cubed plus 54 divided by 2 is 27. So t cubed plus 27. I've got two terms, and the t is cubed. So I look to see if I can do a sum of cubes, which does work, unlike a sum of squares. A sum of squares does not work, but a sum of cubes does. And here we actually have a sum of cubes because I can take the cube root of 27. Cube root of 27 is 3, because 3 times 3 is 9, times 3 is 27. So 3 cubed is 27. So I just keep the 2t out there, can't do anything more with that. But I factor a sum of cubes just like a difference of cubes, except the signs are different. That's all that's different. So I take the cube root of t cubed, put it there, that's t. I'm going to square that to put it there in the first position of the second set of parentheses. I take the cube root of 27, that's 3, put it there. I'm going to square that to put it in the last position of the second set of parentheses. That's where the 9 goes there. The sign in the first set of parentheses is the same as the original one. Then I take t times 3, put that in the middle here, and then the signs in the second set of parentheses are the opposite of the original one, and always plus. And that's how I factor a sum of cubes. And again, that second set of parentheses in a sum or difference of cubes will never be factorable. It will always be prime. Number 7. 25x squared minus 16y squared. Look for greatest common factor. Well, 25 and 16 don't have any common factors other than 1. And there's an x in the first one and a y in the second one, so there's no variable I can take out. So the greatest common factor is 1. It's got two terms. Look for a difference of squares, sum or difference of cubes. Well, everything is squared here, so I can do a difference of squares. So, two sets of parentheses. What's the square root of 25x squared? It's 5x. Because 5 times 5 is 25, x times x is x squared. So I put a 5x at the beginning of each set of parentheses. What's the square root of 16y squared? 4y. So I put a 4y and a 4y. Make one of them minus, one of them plus, and I'm done. Number 8, x squared plus 2x minus 15. This is just an ordinary quadratic trinomial. So I take the negative 15. I find factors of negative 15 that will add together to give me positive 2. Well, I can do, if I think about it, negative 5 and positive 3. Those multiply together to give me negative 15. They add together to give me negative 2, so I don't want that. What if I did positive 5 and negative 3? Those will multiply together to give me negative 15, and they will add together to give me 2. So that's what I want. So I want the 5 and the negative 3. So I've got two sets of parentheses. X plus 5, x minus 3. The signs match the signs of the numbers I had to choose. And the order I put those sets of parentheses in doesn't matter. I could do x minus 3 times x plus 5. That's the same thing as x plus 5 times x minus 3. Multiplication is commutative. That's the commutative property of multiplication. Number 9. 15t squared minus 16t plus 4. And for greatest common factor, it's a 1. So I factor it as a quadratic trinomial. This time there's a number in front of the squared term. My leading coefficient is something other than 1. So the way I deal with that is I take that and I multiply it by 4. So 15 times 4 is 60. And I'm going to find factors of 60 that will add together to give me the middle number, the negative 16. Okay, well I know 60 is 6 times 10. If I make them both negative, they will multiply to give me a positive 60, which is what I want, and they will add to give me a negative 16, which is what I want. Okay, but now I have an additional step. If that number in the front is not 1, like it is not here, here it's 15, I need to either divide one of my factors by 15, which I don't want to do because 15 doesn't go into 6 or into 10, or I split up 15 into two factors that do divide into the numbers I've chosen. And I can split up 15 as 3 times 5. And I can divide 6, or negative 6 by 3, and negative 10 by 5. So I'm going to do that. Negative 6 divided by 3 is negative 2. Negative 10 divided by 5 is negative 2. Alright, so I have two sets of parentheses. The first terms in each set of parentheses are going to be the numbers I split up my leading term with, the 3 and the 5. So 3t and 5t. The second terms will be the numbers that I've gotten ultimately from the 60, which here are -2 and -2. They happen to be the same here, but here's what I would do if they were not the same. The number I would get when I divided by 3, which is this -2, needs to go completely opposite the 3, so all the way on the far end. The number I got when I divided by 5, which is this -2, goes opposite the 5, so it's going to go in this other set of parentheses. They happen to be the same here, they're both -2. But if they weren't the same, that's the way we would have to do it. So that this first -2 gets multiplied by that 3, that second -2 gets multiplied by that 5, if we were to FOIL it out. Again, you can always check your answer on all of these just by FOILing it out, multiplying it out. Number 10, 3 minus 2z minus z squared. Now this is funky, because normally we have the squared term first. So let's rewrite it so that the squared term is first. But that negative is attached to it, so it's a negative z squared minus 2z plus 3. Okay? Well, I don't like a negative in front. What I can do is I can factor it out. -1. That means I'm going to divide everything by -1. So z squared plus 2z minus 3. And now I'm just going to leave the -1 out there, and I'm going to factor what's inside the parentheses. So I look for factors of -3 that add together to give me +2. How about +3 and -1? Those would work. So I've got z plus 3 and z minus 1. And then I'm done. And that -1 needs to be in my answer, because this is not an equation. I can't divide both sides by -1 because there are no other side. So it just has to stay there. Number 11, x squared plus 4x minus 3. Alright, greatest common factor is 1, so I take the last number, -3. I find factors of -3 that will add together to give me 4. Factors of -3 would be 1 and 3, and I could take -1 and +3, or +1 and -3. But that's it. Well, -1 plus 3 is 2, and 1 plus -3 is -2. Neither one of those is +4. So what do I do? Well, that just means that it is prime. Cannot be factored any further. So my answer is just the original problem, x squared plus 4x minus 3. My answer is not prime. My answer is the original problem. That is its factored form, is x squared plus 4x minus 3. Number 12, 3x to the 6th minus 48x squared. Look for a greatest common factor. Hey, 3 goes into both 3 and 48. I can take a 3 out, squared out. Alrighty, so 3x to the 6th divided by 3x squared is x to the 4th. 48 divided by 3, well, 3 goes into 4 once, with a remainder of 1. 3 goes into 18 6 times. So we have 16 and a minus, and we already took out the x squared. So we got 3x squared times x to the 4th minus 16. Well, that's two terms. I look for a difference of squares or a difference of or sum of cubes. Well, I certainly have a difference here, but I have a 4th power of x. That's annoying. Except that x to the 4th is the same as x squared squared, right? So this is really a difference of squares in disguise. So we're going to factor it as a difference of squares, where we'll have x squared as our first term in both of them, because that's what we're squaring to get x to the 4th. And then the 4 and a 4, one of them minus, one of them plus. But now we got to be careful, because one of those factors is a difference of squares, is x squared minus 4. So I can keep going with that one. That's x minus 2 times x plus 2. And the other one is a sum of squares, which is always prime. So that is my completely factored form. I took the x squared minus 4 and factored that out to the x minus 2 times x plus 2, because that was a difference of squares. So I did a difference of squares and then another difference of squares. Often when you start with an x to the 4th, that's what's going to happen. Number 13. We're almost there. 4r squared minus 4rt plus t squared. Okay, look for a greatest common factor. The first two terms have a 4, but the last term doesn't. So the greatest common factor is just a 1. So I can't do anything with that. So instead, I take the first term, 4, multiply it by the coefficient of the last term, which is 1. So 4 times 1 is 4. I find factors of 4 that would add together to give me the number in the middle of negative 4. Well, if I do negative 2 and negative 2, those will multiply together to give me positive 4, and they will add together to give me negative 4. Okay? The funky thing about this one are the variables, because there's two of them. There's an r and a t. Don't let that scare you. You're just going to do an r and a t in both positions in both sets of parentheses. But before I go any further, I need to divide either by 4, which I don't want to do because 4 doesn't go into negative 2 or negative 2, or I can split up that beginning 4 times 2 and divide each of them by 2, making negative 1 and negative 1. Okay? Since I divided both of them by 2, the first terms in each set of parentheses need to have a 2 in them. And they're both going to be r, 2r, so that when I FOIL it, I'll have 2r times 2r, which gives me the 4r squared. Okay? The last term of each one needs to have a t, so that when I FOIL them, I get a t squared. Both of those are going to be negative 1t, because I got negative 1 when I divided by 2 over there on the right. So let's check this. Let's FOIL this out and make sure it works. 2r times 2r is 4r squared. 2r times negative t is negative 2rt. Negative t times 2r is another negative 2rt. Negative t times negative t is plus t. Combine like terms in the middle, 4r squared minus 4rt plus, sorry, that was a t squared, plus t squared, which is what I had when I began. So it does work. I was just checking to show you that you can always FOIL it to check your answer. And when you've got multiple variables like that, it's good to make sure that you did it correctly. Number 14, 3xy minus 4 minus 6x plus 2y. This is the first one we've done where it has 4 terms. When we do 4 terms, we're going to group it. Before I group them, I'm going to rearrange them so that my variables are kind of matched up. And this just takes some trial and error to see if you get it in a way that factors nicely. So maybe I'll move that 6x up to pair it with the 3xy so that they both have an x. And then I'll take that minus 4 and I'm going to put it with the 2y on the end. So I've got 3xy minus 6x plus 2y minus 4. Now let's try grouping it as 2 terms and 2 terms. Okay? The greatest common factor of 3xy minus 6x is a 3x. So I'll take a 3x out of that first set of parentheses, that first pair, leaving me with y minus 2. Okay, now I move on to the second set of parentheses. Greatest common factor of 2y and negative 4 is 2. So I'm going to take out a 2. And I need to put a plus in the middle because I'm still adding these two things together. I'm not multiplying them. So I take that out and I have y minus 2. You want this to happen where your two sets of parentheses ended up being the same. You want that to happen. And when that happens, you can factor that out. Think of this as 2 terms, 3x times y minus 2 and 2 times y minus 2, and factor out the y minus 2 from both of those terms, leaving you with what's left, 3x plus 2. So 3x plus 2. And now you're done factoring it. So when you have 4 terms, often it will work like that, where you can group them 2 and 2, and factor out the greatest common factor of each one, and you'll end up with something in the parentheses on each one that is the same. We'll factor that out, and the other factor is what's left. In this case, the 3x plus 2. The other thing that can happen when you have 4 terms is what's going to happen on here on number 15. X squared minus 4, y squared minus 4x plus 4. So again, I'm going to group them so that the variables are together. I'm going to take the x squared minus 4x, and I'm going to put those up here. Now there's nothing else with the y squared. So let's try putting the 4 with those first 2 terms and then just leaving the 4y squared alone for a second. And I know how to factor x squared minus 4x plus 4. So I'm going to kind of group this as 3 and 1. And let's factor x squared minus 4x plus 4. And again, this just takes some trial and error when you're doing 4 terms to figure out how to group it. X squared minus 4x plus 4 factors as x minus 2 times x minus 2. If you don't believe me, work it out, but it does. Minus 4y squared. X minus 2 times x minus 2 is x minus 2 squared. Then minus 4y squared. Hey, that's a difference of squares. I've got x minus 2 squared, and I've got 4y squared, and a minus in the middle. That's a difference of squares. So here's how I factor it. What am I squaring to get x minus 2 squared? Well, I'm squaring x minus 2. I put that in the first position. What am I squaring to get 4y squared? Well, I'm squaring 2y. So I put that in the second position. Make one of them minus and one of them plus. Now it looks weird, but that is fully factored. X minus 2 minus 2y times x minus 2 plus 2y. And again, if you don't believe me, FOIL it out. So here are your immediate practice problems. Hopefully they are on the easier side of things. Factor each one completely. Number 1, 4x squared minus 9. Difference of squares. Number 2, x squared minus 7x plus 12. Look for factors of 12 that add together to give you negative 7. And number 3, 5a to the 4th minus 5a. Factor out the 5a, then you'll have a difference of cubes. And that is the end of sections 4.5 and 4.6.